This is day number 6 video, which is for Tuesday, March 31st. Today we're going to talk a little bit about the common log. And a common log is a log with base 10. You can take of any number. Now we're not going to write it like that because it is a common log. We're just going to write log of an x. That implies the log is 10 even though there's no log written there. The other log is called the natural log, and the natural log has the natural number e as the base, and you can take that of any number, and we won't write it like that either. The natural log is going to be written as ln, and that implies that our base is 5. All right, so what we want to do then is be able to evaluate these on our calculators, because these are the only two bases, the natural log of base e and the common log base 10, that our calculator recognizes. So if I would like to take the log of 10 on my calculator, again, we all have different calculators, but most of the time the log is on the left-hand side, and most calculators, you're just going to hit the log button and hit the number 10 and hit equals or enter, and it will tell you 1. Now that makes perfect sense because remember, down here is our base, this is the exponent, and that's the number. So base to the exponent 1 is supposed to equal 10. So that's exactly what we got going on here. Now, real close to the log button, you're going to find an ln button, the natural log button. So go ahead and take the natural log of 5, and when you do that, you're going to do the same thing, hit the natural log button, hit 5, hit enter, and I came up with 1.609. Now make sure you're going to get these numbers because we need to learn how to work our calculators. Now, what happens though when I want to take the log base 5 of 2? Well, base 5 is not in my calculator. So we have to come up with something, and we got the change of base formula. Okay, the change of base formula allows me to take any log that is given in any base, we'll just call it b, of any number, and we can change its base. And that happens to be equal to the log, and you choose the base, any number n, of the a divided by the log of that same base that you picked n of b. So if I want to evaluate the log base 5 of 2 in my calculator, what I'm going to evaluate is log base 10, or the common log of 2, and I'm going to divide that by the common log of 5. And when I do that in my calculator, and you should be able to do that in your calculator too, I'm going to get 0.43067, but make sure you're going to get the same exact number. Now, when you do this in your calculator, a lot of times you're going to enter it in, it'll come up with the log, and it'll have a parenthesis there. You got to hit 2, close that parenthesis, then hit your division bar, then hit your log, and it'll come up with a parenthesis. Close it, don't close it, hit enter, and you should get the 0.43. But you need to learn how to work your own calculator. So try this one, log base 6 of 3. And make sure that you can get that on your calculator. Well, actually, let's do it a different way. Instead of going common log, let's use the natural log. So that's going to be the natural log of 3, all divided by the natural log of 6. And then do that on your calculator and see if you come up with 0.613. Okay, the next thing we're going to do is we're going to use the definition of logs to evaluate. So I've got 3 equations here. So the first one, log of x, base 3, is equal to 4. What using the definition of logs means is I want to rewrite this in exponential form. So base of 3, exponent of 4, is equal to x. This is a pretty simple one. You're just going to raise 3 to the x power, 3 to the 4th power, and note that x is equal to 81. All right, this one, the base is going to be x, exponent 3 and that's supposed to equal 27. Well, I note that 27 is equal to 3 cubed, so x equals 3 cubed, and if my exponents are equal, just like if my bases are equal, the exponents are equal. If my exponents are equal, the bases are equal, so x is equal to 3. All right, the next one's a little more difficult, but nothing bad. 64 is the base raised to the exponent x is equal to 4. Well, I know 4 cubed is equal to 64, but that's not what the question asked me. It asked me what 64 raised to what power is equal to 4. Well, the inverse operation of cubing is the cube root. So if I take the cube root of 64, that is equal to 4. Well, how do I write an exponent as a radical? And that is going to be as a rational exponent. So 64 to the 1/3 is equal to 4, or x is equal to 1/3. All right, continue all the good work. If you have any questions, please ask me on Google Classroom, and I'll post the next one tomorrow.